So let's start our lecture 13. In this lecture we are going to discuss some very special graphs for displacement time graph. Displacement means symbol S. So here we are going to discuss these kind of graphs and what is the physical meaning of these type of graphs. So concept will be very similar to distance time graph. Today I have somewhat cold. In Chennai suddenly there is weather change, and because of rain and all I got somewhat cold, so you may feel somewhat difficulty. Okay, so if we talk about displacement time graph of this variety, displacement time graph displacement and time graph. So when I was teaching distance time graph, that time I told you the concept of slope, right? So if we target the same concept here, so you can see at this point if you want to draw slope, so slope will go like this, right? At this point if you want to draw slope, slope will go like this, right? See, few things you have to keep in mind. At this location, what is your time t1? At this location, what is your time t2, right? At this location, what is your displacement? Suppose s1. At this point, what is your displacement? Suppose s2. Okay, but problem is when you are on time, you can see time increases in this direction, and displacement can increase in this direction also and in this direction also. I mean, displacement is a vector quantity, right? So displacement can even come in this direction, even it can go negative, but distance cannot. So you can see here this graph gives you idea that when time is increasing, your slope is increasing. Okay, and if you talk about slope of displacement time curve or graph, this is nothing but velocity, right? Remember, slope of distance time graph is speed, but slope of displacement time graph is velocity, right? So if s represent displacement here, then ds by dt is nothing but velocity, right? Totally clear? So how will you judge? What are the things you should judge in any curve? Any curve, either st, vt, at. First thing you should judge, motion is there or not. Next thing, motion is there, then motion is uniform or non-uniform. Then you should check if motion is uniform, then of course velocity is constant, acceleration is 0. And if non-uniform, then of course velocity will not be constant and acceleration will not be 0. So same thing will happen here. You can clearly see because this slope is also representing velocity, suppose v1. This slope is also representing velocity, suppose v2. So point is they are different, correct? Because you can see theta is changing. Suppose here theta is theta 1, here theta is theta 2. So because theta 2 is more than theta 1, so when you calculate slope, tan theta 2 will be more than tan theta 1. So from here we got that, okay, your velocity will increase. Now so if velocity is increasing, then what kind of physical field you will understand? It's like in the initial timings, like from here to here, when time is increasing, you can see distance increment is not that much. But slowly when your velocity is increasing, then you can see you are traveling very high distance, right? So it is like suppose when you have, and one more thing, slope is changing, correct? Slope is changing. So how fast the slope is changing, that will be your acceleration. It means what? If I am saying st graph, so from st graph you got slope, then there are two types of slopes. There are chances, right? One chance, this slope itself can be constant with time, right? So that kind of graph will be straight line. This graph, time is increasing, but this point, at all the points when you draw the slope, at this point draw the slope, it will be like this, right? At this point you draw the slope, same, right? At this point you draw the slope, same. It means all the slopes are same. So here you can see your slope is constant, means velocity is constant. But in this graph you have seen your velocity itself, I mean slope itself, is increasing. So how fast that slope is increasing? Okay, so that is nothing but dv by dt. dv by dt means rate of change of velocity with respect to time, correct? So how fast that slope is increasing. So that slope is increasing, so it means velocity is increasing, it means you have acceleration. Acceleration is not is equal to 0. Okay, it means what? This graph shows non-uniform motion, but this graph shows uniform motion, right? Now next part, every time your velocity is increasing, but if I will draw the in displacement time graph, if I draw this curve, you can see. And one more thing, in mathematics, this curve you will say as increasing curve. Increasing curve. Why increasing curve? Because slope is increasing. For any curve, when you go in this direction on this axis, then you check slope. If slope is increasing with this axis, then you will say increasing, means time curve. Now next, very sorry for this cold. Suddenly, actually, in last night itself, I was thinking that I may get cold, and you know, worst part, whenever I get cold, I get fever also, and sometimes I get body pain also. From last these 2 years, I am getting all these things. Before that, I used to be very fit and fine. Because of all these COVID situations, I could not maintain my regular routine for fitness and all. Anyway, now you target this one. Okay, for this one, what kind of physical feel you will feel? It's like this. You are starting with 0, so it will be like motion. There is no motion rest. After that, with time, velocity is increasing, so you will make sound like this. Like velocity is continuously increasing. But in this case, you can see, I'll change the color. At this point, you target the slope, so slope is giving you this much angle. At this point, slope is giving you somewhat here this much angle. You can clearly see, if this angle is theta 1, this angle is theta 2, then your theta 2 is less than theta 1. You are moving in this direction, but slope is decreasing. When you further, suppose like this, you will reach here. So at this point, if you find out slope, is it exactly straight line? So suppose theta 3 is equal to 0. So of course your tan theta is equal to 0. It means what? What is tan theta? Tan theta is representing slope. Slope of st. Slope of st means velocity. It means what? Exactly at this location your velocity is 0. Right? At this location, at this time your velocity became 0. It means what? The particle which was moving, that particle came into rest. Particle came into rest. Right? At this location your velocity will be something. At this location your velocity will be something. Actually, I should not write velocity here at time axis, but for understanding purpose I am writing here. I can write like this. Like here velocity is v1, here velocity is v2, and here your velocity v3 is equal to 0. You can clearly see in the beginning velocity had some slope, because at this location if you draw the slope, it will be maximum. Right, maximum slope. And see here, see the difference. When your curve starts like this and when your curve starts like this, what is the difference? Difference is, at this point your slope is like this, right? I mean, exactly, I should not draw like that. Somewhat like whatever curve is there, according to curve position you will be having some slope, or it depends on the curve. Your curve may give you 0 slope here, no problem, but you can see like here you have 0 slope, almost 0 slope. It depends on the curve. I mean, your curve may touch like this, then you will draw curve like this. Your curve may touch like this, then you will draw curve like slope like this. Your curve may touch like this, then you will draw slope like this, right? But in this case like this, so already you got some slope. Or maybe if curve is like this, then this slope, or maybe when curve is like this, then this slope. So you can see slopes are there, but when you are increasing with time, then this slope is decreasing, like this, like this, like this, like this. Slope is decreasing. So when slope will be decreasing, then velocity is decreasing. And if velocity is decreasing, then what kind of sound you will make? And finally velocity is being 0, then it will be like stop. Okay, like this. So your acceleration is known as now retardation. You say retardation or you say negative acceleration. In both the cases your velocity decreases. We say retardation or negative acceleration, right? So this is also Motion is there? Yes, motion is there. What kind of motion? It is a non-uniform motion. Why motion is non-uniform? Because slope in the bracket, you see velocity is decreasing. So if velocity is decreasing, then what is the rate? Like at which rate velocity is decreasing? That is nothing but rate of change of velocity with respect to time. That is nothing but acceleration, right? Okay. So now we are sure that our slope is decreasing. So let's understand this part now. This kind of slope, it means what? Here in the beginning, this is displacement time graph. In the beginning, when your time was this much, at this much time you had this much displacement, okay? But when time was increasing, your so see how many things are happening here. First thing, you can see this was your slope at this location, this was your slope. You can see slope is increasing, slope is increasing, right? You can clearly see slope is increasing, slope is increasing. Okay, if slope is increasing, then one thing is clear, velocity is increasing. But one more thing is clear. What is that? Your object is returning to its reference point. Why? Because slowly displacement is like this and coming zero. Displacement becomes zero, but velocity is increasing. This kind of phenomena where can you see? In case of pendulum, when you are taking pendulum here, right? So after, when pendulum is coming here, after that leave the pendulum, then pendulum will go back. So when pendulum will go back, its velocity will increase, but pendulum is going to its own position, its own location, right? Okay, done. Now next part. Suppose these kind of options you can give. I mean, these kind of physical field you can get in terms of when you throw when you drop a ball from a certain height. Suppose this is the earth surface, and at this height you have a ball. So you throw the ball. So when ball will fall down, then what is happening? In the beginning you had this much displacement with respect to this earth surface, but when the ball will fall down, then ball will gain speed, right? So velocity of the ball will increase, but what will happen? Velocity is of course increasing, but ball is coming and hitting the ground. So when ball is hitting the ground, then velocity is maximum, right? But displacement is zero, right? So see, whatever situations we have seen here, in these situations we understood that only few things you have to crop. Slope, what is slope? So slope of ST graph will be if it is a distance, then it will be speed. If it is displacement, then it will be velocity. Very clear, right? Okay, now I am giving you a situation. In that situation, what do you think? What kind of slope will come? So see, suppose this angle is theta, a car is there, this car will go in this direction, okay? So car is going in this direction with constant velocity. Like on this hill, car is running up, so car is reaching here, okay? After that, what is happening? Brake fails, engine is not working, so car is sliding back, so car is falling back. So from A to B, and when the car will reach to again to A, means like A to B to A, I want to draw the graph. So how will I draw the graph? Idea is very simple. See, when car is when car is going in this direction, it is taking time. Of course, time is increasing, and it is covering distance, right? Or you can say displacement. Displacement is better to explain this phenomena. So displacement is increasing. Now understand, I am drawing displacement and time graph. So when car comes back, that time you have difficulty. When car is going up, that time velocity is constant. So velocity is constant, so constant velocity you draw like this, okay? So suppose time was increasing, displacement increasing, time increasing, displacement, time, displacement, increasing. Suppose when you are reaching at point B, so this location, this condition is represented here. It means what? In this much time you have covered this much distance and you have reached to that highest location. After that, engine stops, brake fails, so car comes down. So when car is coming down, that time, why car is coming down? First question, why car is coming down? So car is coming down because of gravity. So gravity is one kind of acceleration. So one thing is very clear, that acceleration is there. So of course, if acceleration is there, then acceleration is not zero, it is there. Then your velocity will change, and in this case it is falling down, so velocity will increase. So if velocity is increasing, then what kind of graph you should draw? At the see how many things you have to cover in that information. First thing, acceleration is there, velocity is increasing, and displacement is decreasing, and when it will reach here, it will go zero. So what kind of graph? So this kind of graph you will draw, curve line. Okay, curve line. I hope totally clear. Okay, now see, okay, this is over. Now next part, we have done our distance time graph and some important questions. Now we have done displacement time graph. Now question, after these two topics you have to revise your notebook. Okay, now in next video I will cover speed time graph, and then velocity time graph, and then acceleration time graph. Now see, in these three graphs we have to bother about area also and slope also. So for that, remember, area of VT graph will give you acceleration. And one more thing, you should watch this series from lecture 1, because if you are watching from lecture 1, then only you will be having then only you can understand my teaching style and everything. Okay, and all the content, if you are covering from lecture 1, then only it will be very, very helpful, because many things I am continuously explaining from day 1 class. Okay, so you have to complete the entire playlist. Before completing the playlist, make sure you have a fresh notebook. Go to market, get a fresh notebook, and when I'll be finishing this 1D motion, one dimension motion in kinematics, after that we'll solve all the toughest problems from all standard books and from like all the IIT questions and everything. Actually, see, today I have some kind of I'm very sorry for this inconvenience. Guys, do one thing, if you have your WhatsApp number, then in the description I have given WhatsApp link. So using that WhatsApp link, you can join my WhatsApp group. Many students have not joined yet. Okay, only few students have joined. So you too join the WhatsApp link, and in WhatsApp I will be giving you, so we can have a very good discussion, doubt session and all in WhatsApp also. Okay, thank you.